section 1.4 is on angles and their measures. So an angle is an object that's formed by two rays with the same endpoint. The rays are called the sides of the angle, and the endpoint is the vertex of the angle. I'm sure you guys know what I'm talking about here. So these are the sides. This is the vertex. Right? So you can name an angle in several different ways. So the angle on the right can be named in 3 different ways. So I could call this angle B. I could call it angle FBA, and I could call it angle ABF. Okay. So if you're naming it with one single letter, you need to make sure that that's the only angle that has that single letter. Okay, so looking at something like number 1 below, see how I could not call anything angle A, because there's actually 3 angles there that have angle A, or have A as the vertex. Do you guys see this angle, and this angle all have A? So you have to be very specific. So that's when we would use the three letters. Okay, so if I say FBA or ABF, what do you guys notice about the middle of those letters? B's in the middle, and what's B for our angle? It's the vertex, okay? I would never be able to call this angle over here, I would never be able to call it BFA, because that would be the angle right here. That would be this angle, okay? Make sense? All right, so name the angles in the figure. So I'm naming the angles in the figure. I have angle BAC, or I could also call it what angle? Not angle A, but I could call it what? CAB. I could do CAD, or I could do angle DAC. So those were the 2 smaller angles. And then let's talk about the total angle, the big angle. Angle BAD or DAB. Yes, DAB. All right, so number 2, so it says name the angles in the figure. So same idea. So we could have angle RSU or angle USR. I could have UST or angle TSU, and I could have angle TSR or RST. Now, what do you think the measurement of angle TSR is? How many degrees do you think that is? Yeah, it's 180 degrees. That's what we call a straight angle. Okay, so it's still an angle. It's just what we call a straight angle. In other words, a straight angle is kind of just like a line, right? So, but it's still an angle. All right, so the measure of an angle is written like measure of angle A. Yep. Okay, so if we want to talk about the angle measurement, like if I want to talk about the fact that that straight angle was 180 degrees, I would say the measure of angle TSR is equal to 180 degrees. But if I just want to talk about the object itself, just the angle, I don't have to put that little m in front of it, right? So that means it's a number associated with it. It's kind of like when I was telling you the difference between A, B with a line, or A, B without a line. A, B without a line over it is the length of it. Okay, so same idea with angles. If I have the m, it's a measurement. All right, so if I just talk about the object itself, I just write angle A. So congruent angles are angles that have the same measure. So we say their measures are equal. So we say measure of angle A is equal to measure of angle B. So numbers are equal. But the objects are what we call congruent. Have you guys heard the word congruent? Do you know what that means? So that we would say angle A is congruent to angle B. So our symbol is an equal sign with a little tilde or whatever, tilde, over it. So that means congruent. Okay, so do we know the 4 different things? Acute, right, obtuse, straight. So an acute angle is something like that. It's smaller than how many degrees? Smaller than 90 degrees, exactly. A right angle, what's it?
90 degrees.
90 degrees. Obtuse angle? Between what 2 numbers?
90 and 180.
Yep, 90 and 180. I didn't really draw mine obtuse, did I? So let's make it a little bit bigger. So it's bigger than 90 degrees. And then a straight angle. is exactly 180, exactly. So you've all seen those before, hopefully. All right, so find the measure of each angle using a protractor. So this is where students have a hard time measuring angles. And I kind of am going to take you back to that. Remember I said I taught that IU class that was teaching elementary teachers how to teach geometry to their students. It was a little scary. People didn't know how to measure angles. So we're never going to leave high school without knowing how to measure angles, right? You guys are going to figure this out right now. So when you take your protractor and you put it on here, so the protractor is the thing that looks like this, right? And it has these different angles in it. There's two things I want you to notice. Okay, this hole on your protractor or the bottom of your protractor needs to line up with either 0 degrees or 180 degrees. So it's going to line up along that line with either 0 or 180. Do you understand what I'm saying by that? Sometimes you have like a little protractor that has like a little crosshairs thing. Okay, so this one has like one of those little crosshairs. And you're going to put your point, your vertex, right there on that hole. Okay, so everybody look at their own protractors and figure out what we need to do. Do we need protractors? Let me come around with some. Okay, so as I was saying, like you want to make sure, like this first one's an acute angle, so if it's pointing to, I think I looked at Romans and it was like around 57. That's why it's kind of nice to use that smaller protractor that I gave you. So it's around 57, 58. So we're going to use that number instead of the 120 number, right? Like 122, 123. We're not going to use that because it's not obtuse, so it's acute. So it looks like it's 57 degrees. And then the next one, what did you guys get for B? 40? Okay, did you guys get around 40? Okay, so for this one, you would put your line here. So your protractor would be like around here. And then you'd find that one. Or you could do it the other way. Like you could also put your protractor here, whoops, here, and then measure this way. That's why we have angles on both sides. So you have like a 40 and a 140 on both sides, right? And it's acute, so it's the 40. And then this one, what do we get? Like 130 something? 130? Is it perfectly 130? Okay. All right, good. Does this make sense? All right, so the protractor postulate is very similar to the segment addition postulate. So the protractor postulate just says, you know, the measure of the angle, well, kind of like the segment, the distance formula. I don't know what to say. Remember we were talking about like the number line, and if I was going from like -2 to 5, it would be a total of 7. That's what the protractor postulate's like. So it's saying, you know, with this little red line here, if I had, it looks like 15 degrees and this one goes to 140, then what do you think this angle is going to be? 125. So we could do it that way, but it's much easier to move the protractor so it's lining up with something already. Okay, and an exterior point, or an interior point is a point inside of the angle, so an interior point would be something like this. Exterior point is a point that's outside of the angle. Okay. All right. Oh, so the angle addition postulate is the one that's like the segment addition postulate. So if you think about these as being numbers, let's say I have 50 and I have 20. What would this whole angle measure to be? 70, right? You would just add them together. So the way that we write this is we could say like the measure of angle AOB added to the measure of angle BOC is equal to the measure of angle AOC. So the medium added to the small equals the big. So we're going to use that here. So number 1 says use the angle addition postulate. So we're going to have the measure of FCD is equal to x plus 41. So FCD is here, x plus 41. And then BCF, this angle right here. So I'm going to use a different marking. Notice how I used one swoop here. I'm going to use 2 swoops here, which means that they aren't the same thing. Is x plus 78. And then it says that BCD, so the whole thing, is 95. So how do you think we would create the equation then? It's just going to be x plus 78 added to x plus 41 equals 95. And we solve it out. Oops, 95. Is that 119? So what do we get? So 2x is equal to negative 24, so x equals negative 12. So it's okay for x to equal a negative, but make sure when you plug it in you don't get a negative angle. That means that you're probably wrong, right? If you plugged it in and got a negative. Is it okay with negative 12 though? Negative 12 plus 78, is that good? Yeah, and you can always check. So negative 12 plus 78 would be 66, and then negative 12 plus 41 would be, what would that be? Negative 19. So 19 plus, is that right? 29. So 29 plus 66. I don't know what I said. 29 plus, what was the first one?
66.
Yeah, and that makes 95. So it works in the end. Man, I was struggling there. Too much mental math. All right, so same idea here. So it says VUT. So the whole thing here is 175. VUJ is 17x minus 3. And JUT is 17x plus 8. So find x. So it's the same idea. We're going to do 17x minus 3 added to 17x plus 8 has to equal the total angle of 175. All right, and we solve it out. So we're going to subtract that 5 over and get 170. So I have 34x equals 170. So x is equal to 5. All right, does this make sense? Do you guys understand this? Can I kind of skip through this? All right. So this one talks about racehorses. So it says racehorses wear blinders. So they're not distracted by objects in their peripheral vision. So you guys see horses like wear these little things on the side. So if we have these things on our sides, if I close my right eye, I can only see like from here and then a little bit over here. Are you guys all doing this? So close your right eye. Now close your left eye. You can almost see everything, but not everything that you could have seen with just your one eye. So what happens is, when you wear these blinders, one eye can see from here over to like here, and then the other eye can see from here over to here, and then you kind of have like the amount seen by both eyes, okay? So that's what it's saying. So it says, suppose each eye of the horse wearing blinders has an angle of vision of 110, and the angle of vision seen by both eyes is 50. So the angle in the middle is 50, but this whole blue angle was 110. So it says, draw a sketch below and find the angle of vision seen only by the right eye. So what's the part that you can only see with your right eye alone then? How many degrees? It's not 110. Not with both eyes, it's going to be, let me think. Hang on, now I'm confused. Suppose each eye of the horse. So to find the angle of vision seen by the right eye alone. So there's only, over here, that's the only part. So there's only a certain part that you can see only by that right eye, that you're missing out on if you didn't have your left eye open. Does that make sense? So I think it's supposed to be 60. And then that's the same thing with light bulbs. So it says the backyard of a house is illuminated by a light fixture that has 2 light bulbs. Each bulb illuminates an angle of 120. So if the angle illuminated by the right bulb only is 35, what's the angle illuminated by both bulbs? So we want to find each bulb individually does 120, but then only the right bulb is 35. So if I want to find the amount of yard, so the angle of the yard that's illuminated by both, it would be 120 plus the 35. So it would be 155. So there's a lot going on there. There's another angle here, right, that is also 35 and 120. But together, it makes that 155. It's kind of weird. All right. Can I flip to the next thing? So then often you're going to have to put your skills together by plotting points and then finding angle measurements. We can skip this one, but you guys all, I've seen that you know how to plot points, right? We worked on that. And then you can use a protractor and classify as a right angle, an acute angle, obtuse angle, and so on. Okay. So let's look quickly at section 1.5. So you're flipping through the review because that's something you'll see tomorrow. And we're going to go to angle pair relationships. This is where we'll end today. Okay, so adjacent angles are angles that have a common vertex and a common side. So adjacent angles would be this angle here that I'm drawing in red and this angle here that I'm drawing in blue. they share one of the sides of the angles. Do you guys see that? Okay. So it says use a protractor to draw two adjacent angles LMN. So LMN. And also NMO. So that LMN is acute and LMO is a straight. Oh man, I didn't do this right. I want LMO to be a straight angle. So how do I have to adjust it? Where do I need to put this ray? Yeah, going down like that, right? Does that make sense? So this one's an acute angle, and this whole thing here is a straight angle. Does that make sense? So this next one says draw two adjacent angles such that RSP and PST, so the RST is obtuse. So if I start with RSP, and then I want PST, but I want to make it so that my RST is an obtuse angle. So if I just did like PST here, that wouldn't work, right? Because that would not be an obtuse angle for RST. So I want to adjust it, and I want this angle to be like maybe over here, and that would work. Does that make sense? Okay. So this section is all about two different types of angles. So there's an angle that we call a vertical, so we call an angle pair vertical angles, and that's going to be an important one. So vertical angles are two non-adjacent angles formed by two intersecting lines. So we have an angle, or we have two lines that form like an X shape. The outer, so like the right and left angles there, those are what we call vertical angles. Well, what about the top and the bottom? Those are also what we call vertical angles. So imagine I have two big sticks or two rulers. And if I move these rulers, so I make an X shape, and then I make it smaller and bigger, right? So if I'm making an X shape, do you guys see how the ones across from each other are always the same size? And it doesn't matter what X shape we have, the ones that are across from each other, like the top and the bottom and the right and left, are all the same. That's true. So vertical angles are congruent to each other. So it doesn't matter how big you draw the X, these two angles across from each other are the same. These two angles across from each other are the same. So notice how I'm using, like, I could do two marks, I could do a mark with a little thing there, I could do one mark. There's lots of ways to mark congruent angles. Okay, and then the other one is called a linear pair, so that's also an important definition for us. So a linear pair is a pair of adjacent angles where they're opposite rays, so it has opposite rays here, that form a line. So two of their sides make a line together. Does that make sense? So like this angle and this angle, they're not congruent to each other, but maybe one of them is like 130, the other one would have to be 50 then. They're going to add to be 180. So the word supplementary means add to be 180. Okay, so we're going to answer the questions on the right. So it says, are 1 and 2 a linear pair? So are angles 1 and 2 a linear pair? Yes or no? Yes, they add up to be 180. Are 4 and 5 a linear pair? They're adjacent angles, right? Do they make 180? No. Are 3 and 5 vertical angles? Do they make an X shape? Kind of, but it's more like a K shape, right? So they're not congruent to each other, so this is no. Are 1 and 3 a vertical angles? Yes, they make that X shape, okay? So when we have angles across from each other, across the X, they're going to be set equal. When we have angles next to each other, making a line, they're going to be, you add them together to make 180. So this first one, do I set these two equal to each other, or do I add them together to make 180? You set them equal. They're congruent to each other by vertical angles, right? So these are vertical angles. So we say 19 plus 9x added to 8x, or sorry, not added to 8x plus 25, I just talked about that, is equal to 8x plus 25. We set them equal to each other. So we get x equals, subtract the 19 over, so it looks like 6. And then it says, then find the measure of each angle. So you would go back in and plug in 6. So we'd have what, like 48 plus 25, or 19 plus 54. Both of them add up to be 70. Is that right? 48, no, plus 25. What do I get? 70. What did I do? 45? I did 45. So 73. And this was 54 plus 19. So yeah, that's also 73. They should end up being equal to each other in the end. All right, so same thing here. So 4x plus 3 added to 5x minus 3. So we get 9. Oh, wait, hang on. What should they equal in the end? Yeah. So they should equal 180. So we get 9x is equal to 180. So x is equal to 20. And then we go back and plug in. We get 83. And we get 100 minus 3, so 97. Do those add to be 180? Yeah. Does it make sense? Do you guys get it? Okay, so let's stop there. I'm going to give you your math Excel code, so don't jet out yet.